Swayam Prabha. Digital India. Educated India.
We come across the matrix related to symmetric matrix and we done the diagonalization process. We start with unitary diagonalization. We come across the diagonalization process related to symmetric matrix, and now let us start with unitary diagonalization of Hermitian matrix. So, find a matrix P that unitary diagonalization the Hermitian matrix A equal to 2, 1 plus I, 1 minus I, 3 means all the entries are in the form of the complex. So, Hermitian mean H is equal to Hermitian matrix mean H conjugate transpose, we have to take it. If they are equal, then it is to be Hermitian, or rather we can say that A is a one Hermitian matrix, then A conjugate transpose, we have to take it, then it is said to be Hermitian matrix. So, previously we showed the example that the eigenvalues of A are lambda equal to 1, lambda equal to 4, and the base for the corresponding eigenspaces are lambda equal to 1, V1 equal to minus 1 minus I 1, lambda equal to 4, corresponding eigenvector is half into 1 plus I by 1 plus I by 2 and 1. So, this comes because of determinant A minus lambda I equal to 0 and A minus lambda I into x equal to 0. So, based on this we done the eigenvalue and eigenvector of the problem. So, since the eigenspace has the only one basis vector, so according to Gram-Smith process is simply matter of normalizing these basic vectors. Now, the technique for showing this P1 is V1 by norm V1. So, V1 you know minus 1 minus I 1, norm V1 is inner product of V1 comma V1. So, the inner product of V1 is nothing but that is 1 minus 1 minus I and corresponding 1, right. So, the vector is minus 1 minus I 1. So, these two is a norm, that is minus 1 minus 1 minus I the whole square plus 1 square. So, that will be 1 by root 3 will come. So, this way we can calculate V1 by norm V1. So, it becomes minus 1 minus I by root 3 by 1 by root 3 and P2 equal to V2 by norm V2, that is 1 plus I by root 6 by 2 by root 6. So, simply you have to apply with the norm of the vector, and V2 is you know the vector 1 by 2 into 1 plus I and 1, therefore, corresponding root we can generate it. So, this way we can find the P1 and norm of P1. Now, the unitary diagonalization of the matrix P equal to P1 P2 corresponding this vector you have to write, this vector you have to write. So, minus 1 minus I by root 3, 1 by root 3, 1 plus I by root 6, 2 by root 6. So, this is the way we can form unitary diagonalization by the matrix. So, it is a little tedious. You may want to check this result by showing that P star AP, where P star is nothing but P you know minus 1 minus I by root 3, 1 plus I by root 6, 1 by root 3, 2 by root 6. Now transpose, right, P transpose. So, P, you know what is P? P is minus 1 minus I by root 3 and 1 plus I by root 6. Then you have to take the transpose and then take the conjugate. So, it becomes minus 1 plus I by root 3, that is change the imaginary part minus 2 plus, and then 1 plus I is 1 minus I, and then transport it, it becomes 2 rows first column, and 2 by root 6 is remain as it is, and 1 by root 3 change to the first row second column. So, this way we can do with the transpose and conjugate also apply. So, P star AP you have to do, P star calculated, and A is a given matrix, and then P also we just found out, and then multiply that, it is 2 cross 2, 2 cross 2, 2 cross 2, net turns also is 2 cross 2, and we have a diagonal element. So, diagonal element is eigenvalue, so that satisfies. So, this is a way we can find out even the matrix is complex, and we can do with the what diagonalization process. Next, solving Ax equal to B by LU decomposition method. So, LU decomposition method can be applied with the system of linear equation A11 x1 plus A12 x2 plus A13 x3 equal to B1, and a simultaneous linear equation A21 x1 plus A22 x2 plus A23 x3 equal to B2, A31 x1 plus A32 x2 plus A33 x3 equal to B3. Now, we convert into matrix. So, matrix is A11, A12, A13, A21, A22, A23, A31, A32, A33 into x1, x2, x3 equal to B1, B2, B3. Now, here this is for A, this is for x, this is for B. Now, these steps given below to solve the above system of linear equation by LU decomposition method. Step 1, generate the matrix A equal to LU such that L is the lower triangular matrix with the principal diagonal elements being equal to 1, right, principal diagonal element equal to 1, and U is the upper triangular matrix, means U11, U12, U13, 0, U22, U23, 0, 0, U33. Now, we can write Ax equal to B as Lux equal to B. Let us assume that Ux equal to Y, where Y equal to Y1, Y2, Y3. From equation 1 and 2, we have Ly equal to B. On solving this equation, we get the value of Y1, Y2, Y3. So, this is called as LU decomposition. Now, substituting Y in the equation 2, we get Ux equal to Y, and solve the equation, we get x1, x2, x3 and so on. So, this method of process is called as triangularization. Now, we are going to discuss one example. Solve the system x1 plus x2 plus x3 equal to 1, 3x1 plus x2 minus 3x3 equal to 5, x1 minus 2x2 minus 5x3 equal to 10 by LU decomposition method. Now, we can write in the form of the system of linear equation like this, and then the equation of the form Ax equal to B. Now, we can write the coefficient of x1, x2, x3 is like this, and then into x1, x2, x3 column wise, and right hand side value is 1, 2, 1, 5, 10. Now, step 1, let us write above matrix is LU A. So, the rule is L is a 1, 0, 0, L21, 1, 0, L31, L32, 1, and for upper triangular matrix U11, U12, U13, 0, U22, U23, 0, 0, U33 corresponding the given matrix A. Now, so this is 3 cross 3, this is also 3 cross 3. So, net value is 3 cross 3, that is multiply them, you have U11 first row first column into first column of the second matrix, first row of the first matrix and first column of the second matrix we have U11, and similarly U12, U13 will come, and based on that first row into what second row into first column you have L21 into U11, second row into second column L21 into U12 into plus U22, second row into third column L21 U11 plus U23. Similarly, third row into first column L31 into U11, third row into second column L31 U12 plus L32 U22, third row into third column we have this. Now equate to given matrix. Now two matrices are equal, the corresponding entries are equal, therefore U11 and 1 are equal, equate them. Similarly U12 equal to 1, U13 equal to 1. In the LHS of the matrix, second row first column is L21 into U11 equal to 3, and already you know U11, substitute it, therefore L21 equal to 3 will come. Like that you take the second row second column L21 U12 plus U22 equal to 1, and then L21 value you know, substitute it. So 3 into U12 plus U22 equal to 1 will come. U12 value you know, so 3 plus U22 equal to 1. This implies U22 equal to 2 will come, and similarly second row third column, that is L21 into U13 plus U30, this is L21, and U13 plus U23 equal to minus 3, and you know the value of what U13 is 1, L21 value also you know 3, and U23 value to be determined, substitute it, you can get the value. Similarly, third row first column L31 into U11 equal to 1, U11 1 you know, therefore L31 equal to 1. Here L21 equal to 3, 3 into U13 is 1 plus U23 we do not know equal to minus 3, and then from this U23 equal to minus 3 is minus 6 will come. So like that you have to go to the next part. L31 value you know 1, and then U12 is also 1, then L32. So L32 we do not know, U22 value you know, so L32 into U22 is 2, so which is equal to minus 2, implies what 2L32 equal to minus 2, and then this is 1 minus 1, therefore L32 equal to 1 by minus 1 minus 3 by 2. Similarly, you can calculate the last one. So what are all the value you know? L31 you know, U13 is 1, and L32 minus 3 by 2, U23 is equal to minus 6, and then U33 we do not know, which is equal to minus 5. Then you calculate what this value, right. So 1, then plus 9 plus U33 equal to minus 5. Therefore, this implies U33 equal to minus 5 minus 10 minus 15 will come. So like that we can calculate all the unknown variables and substitute this value in the matrix, so that we have the values of U22 minus 2, U23 minus 6, U333, 3, L213, L311, L32 3 by 2. Now, you know the steps of LUX equal to B, you call UX equal to Y. From the previous two steps we have Ly equal to B. Thus, we substitute in the lower triangle, the main diagonal is 1 1 and you know U2 to 1, right. So, substitute the values of this lower triangle L, L21 and then L31, L32 substitute it and multiply with y1, y2, y3 equal to 1, 5, 0 and then matrix multiplication you do. For first step yn equal to 1 will come, for second step 3y1 plus y2 equal to 5 will come, for third step y1 plus 3 by 2 y2 plus y3 equal to 10 will come. Now, you know y1 equal to 1, substitute it and then y2 equal to what, 2 will come. So, y1 and y2 value you know, substitute here. So, 1 plus 3 by 2 into y2 is 2 plus y3 equal to 10, therefore, y3 equal to 6 will come. Now, consider ux equal to y. So, the matrix U is 1 1 0 minus 2 minus 6 0 0 3 and x1 x2 x3 equal to 1 2 6. So, that the values of expanding this equation is x1 plus x2 plus x3 equal to 1 and substitute the value of x1 minus 2x2 minus 6x3 equal to 2, 3x3 equal to 6. From this x3 equal to 2, x3 equal to 2 substitute in the back track, x2 equal to minus 7 will come. Once you know x3 and x2 substitute in the first equation, so we get the value of x1 equal to 6. So, this way we can find the system of linear equation using LU decomposition. Therefore, the solution is 6 minus 7 and 2. Now, we have a problem solving Ax equal to Bu by LU decomposition. So, in this section we derive the factorization and 2 6 2 minus 3 minus 8 0 4 9 2 is A and corresponding lower matrix triangular matrix 2 0 0 minus 3 1 0 4 minus 3 minus 7 and upper triangular 1 3 1 0 1 3 0 0 1. Now, we have to take the first A matrix into x1 x2 equal to what, corresponding 2 2 3 is the equation B. Now, we can write the lower triangle matrix as what, this one and then upper triangle matrix is this one, x equal to B. Now, we have a step by defining y1, y2, y3 by the equation of upper triangle into this and also rewrite the lower triangle as is equal to B. Now, you have to back substitution or forward substitution because 2y1 equal to 2, therefore, y1 equal to 1 will come. With the help of this, you have to substitute in the second equation y2 equal to 5. With the help of first and second, we have to substitute y3 equal to 2. So, this way we can identify the unknown variable y1, y2, y3. So, the step 4 above, we substitute these values into 6 which yield what, 0 1 3 1 0 1 3 0 0 1 of x1 x2 x3 equal to y1 y2 y3 value substitute it. Now, from the above matrix system and back substitution you do that is 1 into x3 equal to 2. So, this value substitute here we have x2 equal to minus 1. Once you know x3 and x2 substitute here, so that x1 equal to 2 will come. So, this way we can find out the values of x, y, x1, x2, x3 by with the help of the forward and backward substitution using LU decomposition method. Now, next problem, find LU decomposition of A equal to 262 minus 3 minus 8 0 4 9 2. Now, we have reduction to row echelon form, right. So, 3 2 6 2 minus 3 minus 8 0 4 9 2 row operation. From this step 1, I may do the first row divided by half, therefore 2 by 2 is 1, 6 by 2 is 3, 2 by 2 is 1, and then second row keep as it is, third row also keep as it is. Step 2, actually what we have to do is multiply the first row with 3 and add with row 2, so that the second row will be keep first row as it is, and second row is 0 1 3 using this operation, and third row keep as it is. Now, we have a LU decomposition, and we will reduce A to a row reduce form using Gauss elimination method and calculate L from the equation. The steps are as follows. So, elementary matrix corresponding to the row operation and inverse of elementary matrix we have to do with the help of E1 and E1 inverse, and E2 corresponding to E2 inverse, and then we have a corresponding step 3, we have to use minus 4 into row 1 plus row 3, therefore, we can use with E3 as like this, and then E3 inverse corresponding calculate it, and step 4 you have to do with the row reduce 3 times of row 2 plus row 3, and corresponding E4 is 1 0 0 1 0 0 3 1, and E4 inverse you have to calculate corresponding. So, 1 0 0 0 1 0 0 minus 3 1. So, inverse you have to do A transpose cofactor divided by determinant of E4, like that you have to do, and further you have to do with the row reduce by 7, so that matrix will come like that, corresponding E5 of the triangular matrix, and E5 inverse also calculate with the help of the inverse matrix, and we have L is equal to all these things you have to do the corresponding matrix. So, E1, E2, E3, E4, and multiply them, you get the values of what L, we get it. So, the matrix can be written as LU combinations is this L you get it, and corresponding what U also we can do. So, this way the another technique we can use for LU decomposition method. Now, construction of an LU decomposition, we will reduce A to a row echelon form U, and at each step we will fill in an entry of L in accordance with the 4-step procedure above. Suppose you take a 6 minus 2 0, 9 minus 1 1, 3 7 5, and then what you have to do for L, you have to calculate upper triangle matrix 0, you have to fill up. Now, you have to do the first step multiplier by 1 by 6, so that what first row will be 1 minus 1 by minus 2 by 6 is nothing but minus 1 by 3, and last entry is 0, and keep second row as it is 9 minus 1 1, and third row 3 7 5. Therefore, corresponding entry here we taken as a 6 you fill up, rest of them with the help of this idea you have to do Z6 0 0, and you have to be blank and fill up with the next step, you do that, and for the next step you have to make the leading element below is 0, therefore, you have to multiply with or divided by 9 and subtract them, so that 0 2 1 will come, and third one also you divide by 3 and subtract them, you get 0, 8, 5 will come with the along with the first row. So that what entry you have taken, that you have to fill up here 9 and 3, and then you have to take the next step. So, here second row, second column entry is 2, that you have to make a 2, therefore, you have to divide 2, so that it becomes 6, 6 already fixed, 9 already fixed, 3 is fixed now. Instead of 2, instead of 1 we have to fix the 2 here, and then in the last row, the n circle, blue n circle, you have to multiply with divided by 8 and then subtract with the next row, so that it will be 0, and then you have to 8 carry here, and then the last one 1 divided by 1 you have to take it. So, we can form a lower triangular matrix with the help of the row reduced matrix. So, there is a very simple, in the leading of the entry is 1, and corresponding here upper triangular matrix generated, and here lower triangular matrix also generated, and then we have what L and U. We can easily construct LU decomposition, and we leave it for your confirmation and multiplying the factors. So, this matrix is L lower triangular matrix, this is upper triangular matrix. So, LU decomposition are not unique. For example, if A equal to LU, which is equal to L11 0 0, L21 L22 0, L31 L33 L33 and upper triangular matrix. Now, L has a non-zero diagonal entries, which will be true if A is invertible, and we shift the diagonal entries from left factor to the right factor. So, that 1 0 0, L21 by L11 1 0, and L31 by L11, L32 by L22 1. So, that the first entry you have to do that. Second main diagonal of the lower triangle you have to write it. Third upper triangle of the matrix you write it. Now, the matrix having the format like this, and combine multiply these two matrix, you have this result. So, which is the another way of finding the LU decomposition of A. Now, we have to demonstrate the LDU, where LDU is a lower, diagonal and upper matrix, multiply them, and then how to decompose the matrix. So, the method we have given for computing LU decomposition may result in an asymmetry, in that the matrix U has ones on the main diagonal, but L need not. However, if it is preferred to have ones on the main diagonal of both the lower triangular factor and upper triangular factor, so we can shift the diagonal entries of L to a diagonal matrix D and write L equal to L dash D, where L dash is the lower triangular matrix with ones on the main diagonal. For example, a general 3 cross 3 lower triangular matrix with the non-zero entries on the main diagonal can be factored as A11 0 0, A21 A22 0, A31 A32 A33 corresponding 1 0 0, A21 by A11 1 0, A31 by A11, A32 by A22 1, and multiply with the diagonal matrix A11 A22 A33 corresponding to the diagonal. So, note that the column L dash are obtained by dividing each entry to the corresponding columns of L by the diagonal entry of the in the column. For example, if you have a matrix 2 6 2 minus 3 minus 8 0 4 9 2, then what you have to do, split it into upper triangle and lower triangle. Then already we done this one, refer it. so that this upper triangle, lower triangle we can convert it. Now, what you have to do? First A22, this is A11, this is A21, divide A21 by A11, therefore, putting minus 3 by 2, already having minus, no issue at all. And then third row first column is A31 by A11 and next column 0, 1, minus 3 and the last one is keep as it is, that is divided by 7. Now, you have to take the main diagonal 2, 1, 0, 1, 7 and upper triangle matrix you have to do that. So, this seems to be that A is invertible, then only it may be reduced to row echelon and can be factored uniquely with A equal to lower diagonal upper triangular matrix. So, this is the technique we can use for LDU decomposition and can be multiplied to the procedure of LU decomposition with ones are in the main diagonal of L rather than U. So, where L is a lower triangle matrix with ones on the main diagonal and D is the diagonal matrix and U is upper triangle matrix with ones on the main diagonal. So, this is called as LDU decomposition or LDU factorization of A.